I'm about to give you a recipe, but this recipe isn't meant to fill your stomach. It's meant to create life out of nothing. The year is the early 1600s. One of the most respected scientists of his time is working carefully inside his laboratory. His name is Jan Baptist van Helmont, and his goal? To create life from non-living matter. Even more surprising, he claimed he actually succeeded. In his writings, he explained what he believed was the secret of life, and he gave the world a strange recipe. Take a dirty, sweaty shirt, add a handful of wheat grains, place them together inside an open container, then wait exactly 21 days. According to Helmont, something miraculous would happen. The wheat would ferment in the sweat and suddenly transform into living creatures. Yes, real, living mice. Running, jumping, fully formed adult mice. It sounds unbelievable today, but one of the most famous chemists in history truly believed that sweat and wheat could turn into life. This idea had a name: spontaneous generation. For centuries, people believed that life could simply appear. Maggots from rotting meat, frogs from mud, creatures forming out of nothing. Today we laugh at Helmont's experiment, because we know what really happened. The mice weren't created there. They were simply coming to eat the wheat. But in a strange way, Helmont was asking one of the greatest questions in human history. How did lifeless matter become living beings like us? How did atoms and molecules come together to think, breathe, and feel? If dirty shirts weren't the answer, then what was the real recipe for life? How did that first spark ignite? Welcome. In this journey, we're going to chase one of the biggest mysteries in the universe. How did life begin? Let's rewind time. Around 4.5 billion years ago, Earth was still a newborn planet. But this was not the peaceful blue world we know today. Scientists call this era the Hadean Eon, named after the Greek underworld, Hades, and honestly, the name fits. Imagine standing on the surface of early Earth. The ground beneath your feet is barely solid, cracking with heat. Volcanoes erupt constantly across the horizon. Meteorites rain down from space. And the sky? Not blue. Instead, it's thick with methane clouds, glowing orange, sometimes even pink. Now imagine the oceans. Recent simulations from researchers at Nagoya University suggest something surprising. Early oceans may not have been blue at all. They might have been emerald green. At that time, there was almost no oxygen in the water. But there was something else, huge amounts of dissolved iron. When sunlight hit the oceans, that iron changed the color of the sea, creating a deep green glow. But if you somehow traveled back in time to this world and survived the heat, the first thing you would notice wouldn't be the volcanoes. It would be the smell. A strong, overwhelming smell of rotten eggs. Volcanoes were releasing massive amounts of hydrogen sulfide gas, enough to make the entire planet stink. And floating through the air was another dangerous gas, hydrogen cyanide, carrying a faint, bitter almond scent. For hundreds of millions of years, Earth remained a hostile world like this. Then, slowly, things began to calm down. Meteor impacts decreased. The oceans stabilized. The chemistry of the planet started to settle. And then something extraordinary happened. One of the most important events in the history of the universe. A molecule appeared, capable of copying itself. That moment changed everything, because once self-replication began, evolution could begin. Variations appeared. Some copies were better than others. Natural selection took over. Eventually, simple cells formed, and life had begun. But here's the problem. This explanation sounds simple, yet the real story is incredibly complex. So today, we're going to investigate the mystery like detectives. Did life emerge from a chemical soup? Did it begin near volcanic vents deep in the ocean? Or did the ingredients of life arrive from space? Maybe a bit of everything. Let's go back even further, to a time before the first cell existed, before even organic molecules filled the oceans. A silent, empty Earth. And this is where our real investigation begins.